Can giant automated steel walls save Europe's richest port? A massive wall of white steel, taller than the Eiffel Tower if stood on end, slowly swings shut across the shipping channel of Rotterdam. This is the Maeslantkering. It protects Europe's busiest port, an economic engine driving billions in trade. How does this colossal barrier decide to seal off a nation entirely on its own? Look down from a drone over the Zuid-Holland coast. You see a sprawling labyrinth of concrete docks, towering gantry cranes, and massive container ships navigating a channel wider than 2 football fields. This is the new waterway canal in Rotterdam. It serves as the main artery for a port footprint stretching over 40 kilometers. Every day, dozens of giant cargo vessels glide through this gap. They carry a massive portion of the cargo bound for the European continent. Yet the entire scene sits a staggering 2 meters below the average level of the gray North Sea, humming just beyond the horizon. But this massive gateway of global trade hides a silent, dormant giant resting on the canal banks, waiting for the perfect storm. A single rogue wave crashing over the dikes here could instantly paralyze a massive economic engine. According to a study by Erasmus University Rotterdam, the Port of Rotterdam's total economic impact reaches 45.6 billion euros, which equals 6.2% of the entire GDP of the Netherlands. Most people assume human operators sit in a high-tech control room, watching weather screens and pulling a manual lever when danger approaches. But humans panic, make mistakes, and miscalculate storm surges. If a crew hesitates for even 1 hour during a midnight tempest, the rising sea will breach the inland canals, drowning Rotterdam's automated terminals under several meters of salt water. The entire system must rely on a computer brain that operates completely alone, with no human backup to save it if the software freezes. Yet the sheer physical forces of the North Sea are designed to tear any static barrier right out of its concrete foundations. Inside a glass-fronted command center overlooking the shipping channel, a team of Dutch engineers from the Rijkswaterstaat performs a highly choreographed ritual. Every autumn, before the North Sea storm season begins, these specialists conduct a mandatory functional test of the massive barrier. The engineers do not touch control sticks or press physical launch buttons. Instead, they stand in silence, observing digital monitors as the automated system runs its diagnostic checks. Technicians on the concrete docks inspect the massive spherical joints, each measuring exactly 10 meters in diameter, applying specialized grease to the steel surfaces. This annual drill ensures that the physical components can seamlessly transition from static land structures into floating dams. Once the diagnostic checklist is complete, the team steps back, leaving the entire system to run on its own. But this peaceful test run hides a terrifying reality when the real storm of the century actually arrives. 2 monumental steel arms rest on opposite banks of the shipping channel. Each hollow gate, built by the Rijkswaterstaat, is longer than the Eiffel Tower laid on its side. According to the Watersnood Museum, these floating steel arms are 210 meters wide and 22 meters high. They are not fixed walls. If they were solid, the crushing force of a 3-meter North Sea surge would snap them like toothpicks. Instead, they act like hollow ship hulls. When a storm triggers the system, the computer opens valves to flood these steel chambers with water. The massive structures sink precisely onto a clean concrete sill embedded in the riverbed. This ballast system uses the weight of the water itself to anchor the barrier against the sea. But keeping the riverbed clear of silt so the gates sit perfectly flat requires a hidden, violent trick. Every Tuesday morning, a team of Dutch software engineers gathers inside a secure Rijkswaterstaat facility in Utrecht. They do not look at weather maps. They hunt for flaws in millions of lines of code. You might think a system this critical relies on a simple backup button for a human to override the computer during a crisis. Actually, the Dutch built the system to lock humans out entirely. Under the BESW software control system, developed with the Eindhoven University of Technology, the barrier ignores human commands during a storm to prevent panic-induced errors. This strict protocol requires a culture of absolute, almost religious, software verification. If a single line of code fails, the port drowns. To prevent this, engineers run continuous virtual simulations of worst-case failures, testing the system's autonomous decision-making against simulated cyber attacks and physical sensor failures. Yet even the most perfect code cannot stop a physical disaster if the underwater foundations are silently buried in mud. On 21 December 2023, Storm Pia roared across the North Sea. High winds pushed a wall of water directly toward the Rotterdam shipping canal. At the control center, computer monitors flashed red as the surge reached 3 meters above the normal high tide mark. Water News Europe reported that this critical limit prompted the Maeslantkering to shut automatically for the very first time during an actual storm in its 26 years of operation. No human operator pushed a button. The BESW software analyzed the rising water, took total control, and ordered the massive gates to swing shut. The hollow steel walls filled with water and sank perfectly onto the riverbed, blocking the tempest. This automated decision saved the low-lying farmlands and the multi-billion-euro port from a catastrophic deluge. Yet this flawless victory hides a silent, creeping vulnerability deep beneath the freezing waves. This mechanical shield demands a staggering price. Every single hour the Maeslantkering remains closed, Europe's supply chains choke, costing maritime shippers an estimated millions of euros in delayed cargo. Critics argue that relying on a rigid, automated barrier creates a false sense of security while ignoring long-term sea level rise. And they are partly right. Rijkswaterstaat must constantly fund dredging vessels to vacuum silt from the underwater concrete sills, a relentless battle against nature that costs millions annually. Even a tiny stone obstructing the path will prevent the barrier from closing properly. This extreme maintenance regime places a heavy tax burden on Dutch citizens. Yet, a far more terrifying threat is quietly gathering in the deep ocean. Rotterdam keeps Europe's busiest port open by trusting its survival to a machine that locks humans out. This automated sentinel calculates the precise tipping point between economic flow and national catastrophe, closing only when the threat is absolute. The ultimate blueprint here is clear. True resilience requires removing human panic from critical decisions, building absolute redundancy into physical structures, and treating maintenance as an active battle. Contrast this with the United States, where aging flood walls in New Orleans failed in 2005, partly due to fragmented manual systems and neglected upkeep. For the Dutch, safety is not a static wall. It is an active, automated choice. If you want to understand how other nations engineer their survival, join us for our next briefing on Nation Blueprint. That's it from Nation Blueprint. See you in the next blueprint. There's always another system worth decoding.